Good morning, student. Let's start today's class. Today we will discuss about monocrystalline silicon ingots, or the process of fabrication of monocrystalline ingots, silicon ingots, and this crystalline silicon ingots can produce by two methods. First one is CZ and second one is FZ process. Okay, the CZ process is called Jokarski process and FZ is called floating zone. Okay, floating zone process. Okay, then here for building our monocrystalline, uh, we used polycrystalline silicon as a base material. Okay, since we have the polycrystalline is a pure silicon material. In previous classes we have studied that the polycrystalline, how the polycrystalline is made, what is the process of fabrication of this polycrystalline. So we have our polycrystalline silicon. From that polycrystalline silicon we want to create monocrystalline, monocrystalline silicon ingots. Okay, the first discuss about CZ process, which is Jokarski. This is Jokarski process. Okay, those in CZ process, what happened? Now, in an inert gas almost atmosphere, that means in an inert gas atmosphere, a polycrystalline silicon is melted in a crucible. Crucible means one pot. Okay, crystal pot. Okay, in that pot the polycrystallines polycrystalline silicon is melted. Mm, a a seed of a seed crystal is dipped into the melting silicon, and the crystal is removed slowly slowly by continuous turning, while controlling the atmosphere gradation, that controlling the temperature gradation precisely to obtain cylindrical monocrystalline bar. Okay, here what happened, you see, one crucible, let's say, 1 minute, crucible, let's say this is one crucible. Okay, this is one pot. Here polycrystalline plates or coats are there. Okay, and and melt melting the polycrystalline. Okay, then what happened, that the one the one seed crystal, this seed crystal is dipped. Seed crystal means one rod of crystal, or a rod of crystals is dipped into that what into the melting polycrystalline silicon, and rotate and remove. After some time it is removed, that is removed slowly by rotating. Okay, by rotating it is slowly removed. Then the a bar of a what bar of uh, mm, silicon crystal is a monosilicon crystal is built uh, inside or built outside of that seed crystal. That bar of monocrystalline uh, or monocrystalline silicon bar is called ingot. Okay, then by cutting this bar, by cutting this bar, that means we get our bar. Okay, and that bar, okay, this is seed. Okay, this is bar font. Okay, by cutting this bar as a plate. Okay, one plate. Okay, so by cutting this bar, one monocrystalline wafer are obtained. Okay, that that the that plates is called wafers. Okay, and when and by cutting this or by cutting this wafer by any saw, we waste 50% of that material or silicon. Okay, circular wafer thus obtained are additional. Then that circular wafer, what happened? This circular wafer, due to the space management or space good space management, we want square size wafers. So we trimmed the edges of that circular wafer and we get uh, square size wafer. By this trim also many silicon wasted. Okay, then then SI produce impurity. Okay, then but in this process, SI wafer produced by seeded process have many impurities and crystal imperfection. Okay, highly purified SI wafer are produced by using float zone float zone process. Okay, or FZ process, which is more sophisticated and expensive. The float zone method is not used for commercial for producing monocrystalline silicon ingots. Okay, so as, in CZ method there is so many of losses and there is some impurity or imperfection in the silicon wafer. So and the pure ingot or pure silicon ingot can be produced using float zone method, but the float zone method is a sophisticated method and uh, very expensive method. So we cannot use that float zone method in our commercial uh, industry to generate silicon wafer. Okay, so we use CZ process. Now after that, after we getting the silicon wafer, we cannot use that silicon wafer directly to make or we cannot use that silicon wafer directly as a solar cell. There is some process, extra process are there to make a make that to build solar cell from that silicon wafer. Okay, for manufacturing solar cell from silicon wafer, a few processes needed to be performed. Okay, a base material either for the wafer, either of the wafer is P doped first. Okay, since there is in solar cell there is P N junction are there. Okay, so first of all there is one silicon. Okay, so that is the silicon is very the silicon is pure silicon, but we need P-N junction, so we need doped silicon. That means one P type silicon and one N type silicon. Okay, that then after we get a P-N junction and we make or we use that P-N junction as a solar cell. Okay, so first of all we P doped. Okay, first of all that wafer is P doped first. Okay, then the wafer are then etched chemically to remove surface impurity. Okay, after P doped the chemical etching as will happen so that there is removal of surface impurities are there. Okay, then subsequently the PN junction obtained by diffusion phosphorus atoms up to the depth of 0.2 to 0.4 micrometer. That means that wafer first this wafer, you see one figure are there, from figure you can understood. Okay, here where what happened, the crucible is there and here the uh, polycrystalline silicon, melted silicon are there. Okay, then silicon then this is seed crystal. Okay, this seed crystal uh, became a bar or ingots, silica in ingots, and after coating these ingots we get our silicon wafer. Okay, then that silicon wafer doped with P material. Okay, then sorry, then the p material. Okay, this is wafer. Okay, this is p material, this is the wafer, this is only p material doped. Okay, then after chemical cleaning are there. Okay, to remove the impurities. Okay, then that is diffused within the gas plasma. For phosphorus glass diffused within the gas gas phase. Okay, here phosphorus diffused. Okay, so here n type build and here p type also build. So due to phosphorus is a pentavalent impurity, so before we doped p type and after that we doped n type. Okay, so we get our pn junction. Okay, then what happened, then the plasma etching of cell edge are there, because the phosphorus see what happened here, what happened when the phosphorus diffusion is are there, then this is p type material. Okay, then the deposition of phosphorus are there around of that p type material, which is n type material. So we need only one side of that n type. Okay, this is not wanted or not desired. Okay, so the plasma etching done what, that they etched or clean this part. Okay, and we get our uh, p, then we get our n. Okay, so here that is happened in plasma etching cell edge. Okay, then phosphorus glass etching means here what happened, the phosphorus residues etched by that phosphorus glass etching. Okay, then what happened, you see, then end doping is required to be removed from the edge of the wafer by plasma etching. I have already told you, during this process phosphorus diffusion, phosphorus glass tube uh, of phosphorus glass bulbs of at a silicon wafer surface, which must be removed. Okay, due to the phosphorus diffusion process, there is a glass phosphorus glass build up on the surface of the wafer, so that glass bulb or phosphorus glass bulb should be removed by the etching process. Okay, then the last step in solar cell manufacturing is to create metal contact. Okay, an aluminum coating is applied at the rear of the uh, pn junction. Okay, by silk screen printing and dried. Okay, that means the in the silk screen printing, you see here, you see this is the silk screen printing rear side contact. Okay, this. Okay, here what happened, here you see this is the p, that means this 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 wafer have p type and n type, and here you, here one aluminum coating material are there, which is act as a contact. Okay, which is act as a alloy contact or contact material. Okay, then this process by using silk screen printing process. Okay, then what happened, then the subsequent cent, centering centering process ensure aluminum diffusion at the rear, thus ensuring compensation of the undesired and topping there. Okay, that means the centering process, the centering process is ensure that the aluminum is fully doped in one side or and compensating the end doped when undesired end dot are there. Okay, now the front side contact are pointed in the form of a grid and D and a dried. Okay, uh, first of all, the rear side contact are build up, then front side contact are build up. Okay, the application of anti-reflecting coating, normally titanium oxide, ensure better solar absorption. Okay, as a last step, salinity is performed to make electrical contacts. Okay, that means here P type, then N type, then aluminum contact, rear side, then front side aluminum contact, and last step is salinity. Salinity means ensuring that all contacts are good and and electrical contact made. Okay, then this is the process. You see, this is the process. Okay, here here's front side. Here front side silk screen printing, front side grids are there or front side contacts are there, then drying. Okay, then silk screen printing, anti-reflecting coating. Okay, here anti-reflecting coating is there, then salinity FSC or anti-reflecting coating are there. Okay, here you see, this is the upper side is front, this is upper side. You see, this upper side is anti-reflecting coating, then front side contacts here front side contacts are there, then N diffusion layer, then P base material, then P alloy contact. Okay, then a rear side contact. Okay, this is our then we tested that uh, solar cell electric measurement, how many electric or voltage is generated. Okay, this is the process of Jokarski or CZ process. Okay, then then you know, besides silicon single crystal or monocrystal wafer, crystalline wafer have been successfully used by the photovoltaic industries. Okay, polycrystalline is also used in solar cell making industry. Okay, the multi-crystal or polycrystal silicon ingots are produced by using cheaper block casting method. Okay, cheaper block casting method. In this method, EGS or electronic grade silicon is melted and poured into a square shaped silicon oxide cyan coated, and which is SiN coated graphite crucible. After after this, the heat is removed from the bottom of the crucible, then solidified of the crucible result a multicrystalline silicon block. In this process, more impurities get incorporated in silicon due to the large Si to crucible contact area. Okay, here what happened, a crucible are there. Okay, in the crucible there is polycrystals are there. Okay, then melting then the polycrystalline melts, and then the heat is direction is the heat is removed from that polycrystalline sorry, from this crucible. Okay, then the polycrystalline solidified and we get our multicrystalline or polycrystalline blocks. Okay, thank you.